Okay, just wait, I am starting. Okay, so we have discussed that is the canonical form of canonical forms for discrete time state space equations. Okay, so I'm written once again the previous equations. You know that is y of k plus a1 y a minus 1. Next one, that is a2 y of a minus 2. This is the n number of terms. You know a in y of a minus 2. Another one output equations, you know, that is b0 u of k plus b1 u of k minus 1 plus v2 u k minus 2 plus dot 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 n number of terms, that is bn k minus n. This is the equation number 1. So you know that here uk, here uk, that is the input, and yk, which is basically for output. Okay, and it is also number of sampling signals, is k, number of k terms. You know that k is changes, that is 0 to infinite range, and coefficient we have to use coefficient, that is the ai, that is I is equal to 1 2 dot dot number of n, and bj, that is j is equal to 0 1 2 dot dot number of n terms. Okay, now we have to consider this equation 1 in our pulse transfer functions. So now we have to write equation 1 can be written in the form of the pulse transfer functions. We have learned how to calculate the pulse transfer functions in previous classes. Okay, so pulse transfer functions, as you know that is the output of the equation to the input of the equations. So this is b0 first one plus, we express this pulse transfer function in the z transform method, that is b1 z inverse plus another term, you know that b2 z inverse 2 plus dot dot bn z to the power minus 1. Okay, another one, that is also 1 plus a1 z inverse 1 plus a2 z inverse 2 plus dot dot, here plus is also present, plus a in z to the power minus 1. This is the equation number 2. Okay, so we have to consider these transfer functions, that is the pulse transfer functions from the previous one functions also. Okay, is it clear all of you? Now again we have to write the previous equations, that is or that is yz by uz, that is we have to multiply it z to the power n in upper part and lower part also. Okay, that is b0 z to the power n, that is b1 z to the power n minus 1 plus dot dot bn. Next part, that is z to the power n plus a1 z to the power n minus 1 plus dot dot, that is aa. This is the basically complete pulse transfer function for the canonical form of discrete time control systems or discrete time state space equation. Okay, so uh, so this equation, that is equation 1, 2, and 3. So previous equation, that is that is equation 1 and equation 2, another one, that is equation 3. We have to realize the state space representation for the discrete time control system. Okay, and there are the number of four representations are available for this canonical form of state space analysis. Okay, so now types of canonical form for discrete time state space equations. State space equation. Okay, so here four types of classifications are available. Number one, controllable canonical form. Number two, observable canonical form. Number three, diagonal canonical form. And number four, Jordan canonical form. So these four type of discrete time state space equations in the canonical form we have to classify. Okay, so please remember these four terms. It is very much important. Question ऐसे आप लोगों को दिया जाएगा, how many types of canonical forms are available in the discrete time state space equations. Okay, so these four type of equation, that is controllable, observable, diagonal canonical form, and Jordan canonical form. So in this corresponding, the controllable and observable, it is very much important for the discrete time control system in state space analysis. Okay, and in your when you have to show the module 4 in your syllabus, module 4, this controllable canonical form and observable canonical form, it is also described, you have to available in your syllabus in the module 4. We have broadly discussed in the module 4 for the controllable and observable. Okay, but right now we have to also overview idea is given for the what is controllable canonical form, what is observable canonical form. Okay, so this is very much important. So first we have to consider for the controllable. Number one, one minute. Controllable canonical form. Okay. So in the previous equations, that is equation 1, 2, and 3, you have to also imagine, you have to also remember these three equations, because using these three equations, this one, and another one, these three equations we have to calculate in our different canonical form. Okay. So first of all, written here the state space representation of the discrete time system given by equation 1, 2, or 3, 2 or 3, okay, may be put in the form given by the following equation. Okay, so using these two equations, that is equation 1 and equation 2 or 3, we have to express the matrix form in the canonical controllable canonical form. So I am written the matrix form. First, x1 k plus 1, okay, next x2 k plus 1. This is also number of number of terms, that is before the number of n, that is n, x of n minus 1 k plus 1, and last one xn k plus 1. Okay, this is equal to, this is standard form. Please remember everyone. 0, 1, 0, dot dot dot, that is also 0. Then 0, 0, 1, dot dot, that is also 0. Then this is continue of the number of n number of terms. Okay, this is also 0, 0, 0, and then this is also 1. So this is the basically standard form of controllable canonical form. Minus n minus 1, this is also minus n minus 2, and so on. This is the last minus of a1, minus of a1. And what is the constant term? That is also x1k. This is also x2k, dot dot dot, that is of x of n minus 1k, another one x n k. Okay, another 0, 0, dot dot dot, that is 0, last term is 1 for the uk. You know that what is uk? Anyone, what is uk? I am previously given. What is uk? No one is response. This is very bad. What is uk? uk is the input of the system. And what is yk? yk is the output of the system. I have previously written. So please go to the previous one. So this is the basically another equations we have to written here. This is equation number 4. Now this is for the input, that is the x1, x2, number of xn, that is a one variable. Okay, that is a multiple variable, that is the x1 input. Another one we have to express, that is the output, that is yk. This is equal to bn minus an b0. This is a basically number of terms, multiple number of terms, that is b0, then b1, b2, that is the previous one of last ending, that is bn minus 1 minus of an minus 1 b0, that is a multiple terms, dot dot dot, that is also b1 minus a1 b0. Okay. Okay, b0. So this is a form of the output and constant term, that is x1k, x2k, dot dot, that is also xn of k. Okay, plus b0 u of k. This is equation number 5. So here you can see this equation 4 and equation 5. I am going to the 4. This is the form of the matrix form of the state space equations. This is a state equations of the input, and another one is the equation 5. This is for the output state equations. Okay. So now equations equations 4 and equation 5 are the state equations and output equations. Okay, so this is the basically output equations, and previous equation it is for the state equation. This is for the state equations, that is x of n, another one y of k. This is for the output equations. Okay, so this is the basically form of the canonical controllable form. So the state space representation state space representation given by equation 4 and 5 is commonly called a controllable canonical form. Okay, so this is the basically controllable canonical form. Okay, is it clear? Is it clear, all of you?
Yes, sir.
Okay. Sometimes this equation, that is state equations, this representation, we have to also reverse order. मतलब हम इसको रिवर्स ऑर्डर में भी कभी मतलब लिख सकते हैं. जैसे मान लीजिए that is the 100, this one, that is 100, then also 0100. This pattern we have to also follow. Some of books it is also reverse process. It is applicable. So these are the same things. So this is not changes. So now I am given you one example. Then you have to sort given some idea. So ऐसे आपको क्वेश्चन दिया गया है. जैसे मान लीजिए एग्जांपल 1. Consider the system given by. ऐसे क्वेश्चन दिया गया है. मान लीजिए US by YS. This is equal to S plus 3 y square plus 3s plus 2. Obtain a state space representation in controllable canonical form. ओके. सो ऐसे आपको क्वेश्चन दिया जा सकता है. छोटा छोटा क्वेश्चन. ऐसे आपको एक सिस्टम इक्वेशन दिया गया है. दैट इज आउटपुट बाय इनपुट रेशियो. यू नो दैट ट्रांसफर फंक्शन इक्वेशंस. एंड you have to obtain the state space representation controllable canonical form. Okay. So now you have to consider here. So here the highest power you can see is to the power 2. Okay. Highest exponent of the s. That means here n is equal to 2 because highest exponent of s, that is s to the power 2. Okay. So now, so that's why we have to written here, that is a1, first one 3, another one is 2. That is a1 and a2. Okay. Now we have to consider these equations in our state space model in the matrix form. You know that is x1 dot. ऐसे भी हम लोग लिख सकते हैं, डॉट देके भी लिख सकते हैं और कहीं पे जगह में मतलब डैश देके भी लिख सकते हैं. सो दिस आर सेम चीज. सो x dot 1 and x dot 2, two input variable. So this is form 0 1 minus 2 and minus 3 in matrix form for the x1 and x2. Another one, it is also 0 and 1 for u. This is for the state equations for the input terminal. Another one, that is y is considered, that is also 3. Here you can see this is, that is 3. Another one first is also 1. So this is also x1 and x2. Okay, so this is the basically state space representation in our controllable canonical form. So please remember these things also. This is the basically standard form 0 1, and also this is also 0 and 1. This is standard form of the controllable canonical form. Okay. So these sort types of questions are available in your exams also. Another part, that is number 2, observable. Number 2, observable canonical form. Number 2, observable canonical. Everyone go through the your books, that is discrete time control system by Ogata. Okay, in these books there are lots of examples are available, so please everyone practice in your room different applications, different examples. Okay, because here are number of examples more than one. So मतलब क्लास में इतना एग्जाम्पल अगर कराऊंगा तो मतलब सिलेबस नहीं मतलब शेष होगा, ठीक है, सिलेबस को भी टाइम में तो एंड करना है, इसलिए you have to also practice in your room different examples. There are the lots of examples are available. So next one, that is the observable canonical form. So in the observable canonical form, these are the also same we have to express the previous equations. Equation 1, 2 and 3. So I've written here the state space representation of the discrete time system given by equations 1, 2 और 3. प्रीवियस 3 जो इक्वेशन हम लोग डिराइव कर रहे थे उसको लेके हम लोग ये 4 जो कैनोनिकल फॉर्म है उसको एक्सप्लेन करूंगा, ठीक है. सो इक्वेशन 1 आइदर 2 और 3 may be put in the following form. So we have to write the matrix form. That is also, you know, first one x1 k plus 1, x2 k plus 1 dot, that is previous n minus 1, that is k plus 1, and last one xn k plus 1. Okay, this is equal to 0 0 dot dot 0 0, okay, minus an. Another one 1 0 dot dot 0 0 minus a in minus 1. This is a in minus 1 dot dot number of terms multiple, that is 0 0 1 0 minus of a2. Then 0 0, that is also 0 1 minus a1. So here you can see this is a basically changes, because previous one when canonical controllable canonical form we have to express these roots, that is the number of minus a1 minus a2 minus n minus 1 minus n minus an. This is basically we have to written in the this row wise. Okay, but here you can see this is basically column wise we have to written. So this is basically changes for the previous one also. So this is the x1k x2k dot dot x a minus 1 k, another one x of n plus another terms, you know, that is bn for a in b0. This is next one, bn minus 1, n minus 1 b0 dot dot b2 a2 b0 b1 a1 b0. This is for the into UK. This is equation, previous one equation number 5. So this is the also equation number 6. Okay, this is for the representation of the equation, state equations. Now we have to express for the output equations. That is yk. Is it is equal to 0, 0, dot dot 0, 1. Sorry. That is x1k, x2k, dot dot x of n minus 1k, xnk. Okay, plus b0 u of k. This is the output equations of the. This is equation number 7, I think. This is for the observable canonical form of the input equations. Okay. So, one minute. So, the state space representation given equation 6, that is previous one, and 7 is called an observable canonical form. Okay, so this is the observable canonical form. Is it clear, all of you?
Yes.
Okay, so everyone write your own name and roll number in the chat box also. And Neeraj, are you hear me?
Yes, sir.
Neeraj, you take a screenshot, and after ending the class, you have to send both screenshot in my WhatsApp. Okay, so another one, number third, you know that diagonal canonical form. This is diagonally matrix. You have to remember when we have to consider for the diagonal matrix. So this is the same logic. So this is the diagonal canonical form. Okay, so if the pole of the pulse transfer function given by equation 1, 2 or 3 are all distinct, then the state space representation may be put in the diagonal canonical form as follows. So everyone see, it is same one. First one x1 k plus 1, x2 k plus 1 dot dot x in k plus 1. So this is the diagonal form, you know, p1 0 dot dot 0, then 0 p2 0 0 0, then number of in number of terms, that is also 0 0 p of 4. So here you can see this is the diagonal form, p1 p2 pn. Okay, so this is called the diagonal form of the diagonal matrix. So this is the x1k x2k dot dot xnk. Another one, that is 1 1 dot dot also 1. This is also 2. Equation number, I think this is 8. Please consider here, this is the 8 number of equation 8. Okay. Next, the output equations of the equations, that is, you know, yk. This is the coefficient c1 c2 dot dot cn for the different variable x1k x2k dot dot x1k xnk plus b0 uk. This is the equation number 9. Okay, so this is the basically a form of the diagonal canonical. Okay, so in your syllabus, basically question is coming from previous two, that is first two. One is controllable canonical form, another one is observable canonical form. Okay, and third one is diagonal canonical form we have to solve, and another number 4. Please go through the books. That is a Jordan canonical form. So we have to describe this Jordan canonical form in next classes. Okay, this is very easy. Same to same is diagonal form. Okay, this is another process for the pulse transfer functions of the given equations. We have to conclude the next classes also. Okay, so I think it is clear, all of you.
Yes.
Please
Yes.
go through the
Yes, sir.
class notes also. I am upload the class notes in your Google Classroom portal. Everyone read this is carefully. Okay, anyone any doubt or any questions? So we have to ask me in next classes also.